Hello geometry students, this is Mrs. Hefty here, and we're in section 1-5 and we're talking about angle relationships. You were asked to use your book to complete a chart. Now I don't have the identical chart that you have, but you had to identify adjacent angles, linear pair, and vertical angles. You had to write the definitions down, and then you had to give some examples and some non-examples. And so I've just taken exactly what's out of the book here, but you have it in your chart. Adjacent angles are two angles that lie in the same plane, and they have a common vertex and a common side, and they have no common interior points. So if I think of adjacent, adjacent means next to each other. So when you look at the examples 1 and 2, here's the common vertex and there's the common side, and this is the interior and that's the interior, so they don't have any common interior. When you look at your non-examples, you're talking about 3 and angle ABC, and your first one, yeah, they have a common vertex, and you might be saying, well, here's the common side, but they have common interior. That's why that one, those two are not adjacent angles. So next to each other, but they're not overlapping. Linear pair, when you see linear pair, you should be thinking of a line. And if a linear pair are going to be adjacent angles with non-common sides that have opposite rays. So think of two angles that are going to make a line. So if you look at your example 1 and 2, there's an opposite rays, and then there's their common, there's the shared ray. In example number 2, do you see how those two angles are not making a line? The next thing you were asked was to identify vertical angles and give the definition of that. Vertical angles are two non-adjacent angles formed by intersecting lines. So they're the angles across from each other. So if you look at your example here, here's my two intersecting lines. 3 and 4 would be considered vertical angles, and 1 and 2. So it's angles that are across from each other when you have intersecting lines. And when you look at the non-example, do you see that those really aren't two lines that intersect? This is a line, but this is not a line. So that's why that's a non-example. You need two lines. So those would be straight lines. All right, let's take a look at what else we have. You are asked to define complementary angles and draw examples. If you need to pause the video to write this information down, go ahead, and I'm going to explain it. You need to have all the details in your notes. Complementary angles are two angles that add up to 90 degrees. 90 degrees. And so when you look at my example here, that's a 90-degree angle. I should be communicating that by making a right angle marking in there. So 1 and 2 are complementary. So I would write the measure of angle 1 plus the measure of angle 2 equals 90 degrees. They don't have to be adjacent to each other. In this example right here, my angles are adjacent. In my second example, I have a 30-degree angle and I have a 60-degree angle. They are not adjacent to each other. They're not connected. Complementary does not need to be adjacent. I forgot to identify those. That's A and B. So I would write the measure of angle A plus the measure of angle B equals 90 degrees. And remember, when you're having an equal sign and you're talking about angle measures, you need to have the M's for the measures. Then we were asked to identify supplementary angles and then draw two different examples. Supplementary angles are two angles that add up to 180 degrees. Oops. Add up to 180 degrees. So 180 degrees would make a straight line. So in my first example, I have angle 1 and angle 2 are forming a straight line. They're actually a linear pair as well. So how would I write that? I'd write the measure of 1 plus the measure of 2 equals 180 degrees. In my second example, again, supplementary angles do not need to be adjacent to each other, and so I've drawn a 70-degree angle and a 110-degree angle, and I'm going to call this E and F. So I'd say the measure of angle E plus the measure of angle F equals 180 degrees. Got degrees there. Some students struggle with remembering complementary is 90, supplementary is 180. Couple of tricks here that students have told me over the years. C, complementary has a C in it. When you look at 90, isn't there kind of a C in it right there in the 9? So complementary is 90. Supplementary is the S. And isn't there kind of an S in an 8? An S in an 8, so supplementary is 180. That's a trick that some of my students taught me. Let's take a look at the next part. It reads, what is the difference between linear pair angles and supplementary angles? Okay, so linear pair angles share a common ray. So linear pair must be connected, must be adjacent. This is the common ray. Supplementary angles don't have to be connected. This could be 70, this could be 110. So yes, every linear pair is a supplementary angle, has supplementary angles, but not every supplementary angle is going to be a linear pair. Divine perpendicular. Perpendicular are two lines that intersect to form right angles. All right, so now I'm going to draw a picture. This is crucial, people. AB is perpendicular to BC. So I'm going to draw AB, and I need BC. So they're going to share B. There's A, and there's BC. And it's perpendicular. So perpendicular means right angle. So what you need to do, once you see AB perpendicular to BC, then you have a right angle. So as we move into proofs, we're going to write angle B is a right angle. And then what does right angle mean? Right angle means 90 degrees, so that the measure of angle B equals 90 degrees. This is really huge in Chapter 2 as we move through proofs, so keep that in mind. I know what your brain is going to do. Your brain's going to say, okay, perpendicular, and you're going to jump right to 90 just because you have such a powerful brain. But keep that in mind. Perpendicular is right angle, and then right angle is 90. What is the symbol that represents perpendicular? I already did that right here. That means perpendicular. Draw two lines that are perpendicular. What would you do to the picture to communicate to others that the lines are perpendicular? And we've already done that right here, people. We make a right angle marking. So if I have perpendicular lines, I'm going to do a right angle marking. And right angles then are 90 degrees. Let's take a look at our examples. Name an angle or an angle pair that satisfies each condition. So I need adjacent angles, and adjacent angles means angles that are next to each other. So there's a ton of answers here, people. Let's take a look. You can pick any one you want. I'm going to pick this angle right here, angle LTN, and I can pick on either side. I can pick on the left, or I can pick on the right. I'm going to pick on the right here. I'm going to name angle NTE. In the next example, I need to name two acute vertical angles. So I'm going to need an acute angle. I need to find two lines that cross, two lines that intersect. Right, so this would be a line, and that would be a line that intersect. Now this is 110, so that's obtuse. So I need to work with this angle right here, angle RTS. Across from it is LTE. Two supplementary adjacent angles. Okay, supplementary has the S, and so the S is in the 180, so I'm looking for 180 degrees. I'm going to use this 110, angle RTL, and then now I'm looking for one that's going to make a straight line so they add up to 180. I'm going to use this one right here. Some people might be saying they're going to use this one over here. Either one is fine, and angle LTE. Our next example says an angle supplementary to RTS. Here's RTS. You can either use the one above or the one to the right. I'm going to write angle STE. Let's look at exercises 5 through 7. It says use the figure at the right. So I've got to identify number 5, identify 2 obtuse vertical angles. All right, so first I've got to find an obtuse angle, and then I also have to find lines that are intersecting that create an obtuse angle. So I'm looking here, I see these lines are intersecting. This looks like an obtuse angle to me, so I'm going to write that angle down, angle RNT, and then I need the one across from it, SNU. Use my eraser. I like to write on my diagrams, it helps me. All right, now I need 2 acute adjacent angles. So I need an acute angle, and then I need one right next to it. So I'm going to use this one right here. And there's probably more than one answer in this. Angle RNV. And then I need another acute angle that's right next to it. So I could use maybe this one right here, or I could use this one down here. Either one of them's correct. Angle RNS. Identify an angle supplementary to TNU. So I need TNU, and I need supplementary to it. So I need to get 180 degrees. I could use this one, or I could use this one here. I'm going to use my S and U. So a couple of tips. It does help, to take your pencil and kind of trace over the angles to help you find the other one. So I'm done with the first part of section 1.5, and that was day 1. We'll continue with section 1.5 in our next video. You guys have a great night, and I'll see you in class tomorrow.